Hello everyone, welcome back to our computational thinking videos, and this is our part 3. In this video we're going to learn about exhaustive search algorithms. So it's basically about finding the root, etc. So you see from here we have the B, C, A and D. You can also see some numbers here. This is a whole root, and some numbers here are 7, 12, 15 and 10. These are telling us that how much minutes will it take us to get from A to D is 7 minutes, then D to B 12 minutes, B to C 15 minutes and C to A 10 minutes. That's how these all are connected. Now, what is our task? So I've made another route over here, which is connecting B and C, and then C to it's like that. Which is like of 20, which like from B to C it will take 20 minutes. It's like that. So we have to find all the possible routes that are starting from B and ending at B again. So for that, let's look at it. B, D, C, A, B, B, D, C, A, B. But if you see, this is a bit confusing. How can you make it more easier? To make it easy for us to search out routes when there are a lot of possibilities of routes, we use another tool construct from our computational thinking toolbox, which is called abstraction. This abstraction helps us to remove all the unnecessary details in the map so that we can find out the possibilities much more easily. So now I'm taking the shape square. This is my small little abstraction. Because I have 4 points, A, B, C, D, that's why I'm using a square, and then in the middle there's a root. So for that, to show that, I'm going to use a line. Which is like this. Now, our main thing is that we're going to, ease our work. So if I'm saying, by looking at my map, over here, if I have, for example, B, okay, B. Next, beside it, what do we have? It's a D. Over here we have a D. And then beside over here we have C, which is like connecting to B and C over here and B and C over here. That is how we're showing our abstraction. And the left over is the letter A. So we've got all of them in one place. Now, it's like B to A over here we have is 12 minutes. And B to D we have 15 minutes. Then D to C we have 10 minutes. It's 10 minutes. I'm showing my best to show this. 10 minutes. And then we have C to A, 7 minutes. 7 minutes. And B to C we have 20 minutes. That's how we create an abstraction. Now from here we can easily find out the roots. Now when we have made the abstraction, why exhaustive search algorithms are used to find out the fastest and slowest route among all of them, so that the user can take the fastest route to get to their destination. So we have to also search out the fastest and slowest route among all. But how are we supposed to do that? We are supposed to add all the minutes. If it's B to D, then it's like 15 plus, after D to C, 10 plus from D to C, it's C to A, that's 7 minutes. And then we have A to B, which is 15 minutes. Sorry, 12 minutes. And which equals to 42 minutes. Like that, we're going to find out all the possible routes and find out the fastest and the slowest. Now we have done this one. We can go in the reverse direction. B to A, A to C, A to C to D. Look on the abstraction. What I'm saying, C to D, D to B. Then B to C, C to A, A to B. Then B to C, C to D, D to B. What else? We have to start from B and end at B. So these are all the possible routes I can find. Comment down below if you can find more. Now let's see which is the fastest and the slowest route by adding all the minutes. So I've calculated all this out, which shows that BCAB is the shortest route among all, and BCDB is the slowest or the longest route among all. This is the fastest, and this is the slowest. So that's how you do exhaustive search algorithm. Now if the question comes to write a pseudocode to instruct the driver in this particular map, looking through this particular map, to go from point A around the route, ending back at point A. Remember to use while or if and repeat. Now, how can we write this? First, we have to write what we are doing, meaning that we have to instruct the driver about it, right? So we're going to write, drive your car from current point A to current point to the next point, starting at point A. Now we're going to tell the driver to start at its current point, then to the next point, then to the next, then when it is on its current point, then to its next point. Now C is its current point, so to its next point, which is D, then D is now the current point, and then from D to A, which is its next point. But it says starting at point A, because you have to go from point A around the route and then back at point A. Now we're going to use our repeat loop, and we're going to say keep driving, and then if car at point A then stop. So if it's gonna be no, then go back to repeat. That's how we're gonna make the pseudocode for this route. I hope you find this video helpful. Remember to like this video and share with your friends, and don't forget to subscribe to our channel and turn on the notification bell. If you have any queries, comment down below in the comment section. Bye for now, guys. In our next video, remember that it's going to be our part 4, in which we're going to do the continuation of exhaustive search algorithms. This is just finding the route. In our next video, we're going to do the bubble and insertion sort. I hope that you'll join us. But if you want to be notified about every post, then remember to subscribe and turn on the notification bell so that you can be notified every time we post another video. Bye for now. Have a great day ahead.